Hello everyone and welcome to today's webinar, Azure Data Platform Series 2, Data Lakes Are Not Just Another Data Warehouse. I am Megan Souza, Marketing Manager here with Done Solutions Group. Before we get started, I would like to go over a few items. The session will be recorded and we will send out a link to the recording to everyone who registered within 24 to 48 hours after the presentation. We also have recordings of all previous webinars on our website in the event that you missed any in the past at donesolutions.com. Also, if you have any questions during today's presentation, we encourage you to submit them and we'll address as many as we have time for at the end of the presentation. If the question is somewhat complex and we need more time to answer, we do promise to follow up with you for those. So let's take a look at today's agenda. I will begin by doing introductions to Done Solutions Group. From there, I will turn it over to today's presenter, Sunil Parekh, an analytics consultant here at Done Solutions. Sunil will discuss everything about data lakes, how to build a data lake. We'll go over a demo, and then we will cover any questions that y'all may have. So let's begin. Done Solutions has a long history of delivering innovative business technology solutions. We are headquartered just outside of Chicago and have offices in Minneapolis, Raleigh, and Bangalore, India. Our offerings fall into two practice areas. Our application development solutions feature portals, e-commerce, and content-managed websites, mobile application development, and custom application development. Our analytics solutions feature analytics and BI platforms, as well as data warehouses and data integration. We are authorized SAP and Liferay training providers and offer classroom, virtual, private, and custom options. We believe training is important because once we deliver a solution, we want to make sure that those who need it know how to use it and maintain it. Our clients, some of which are included here, are a combination of Fortune 500, mid-market companies, government agencies, and nonprofits across all verticals. About 80% of our business are commercial clients and 20% are nonprofit and government. We maintain strong partnerships with top technology companies in order to offer our clients the most innovative solutions available today. Our analytics practice helps deliver information to decision makers throughout your organization so that it runs better. We can help with decision making by not only looking into the rearview mirror, but also looking forward into the future by leveraging predictive analytics and data mining techniques. I will now turn over the presentation to Sunil. Welcome, Sunil.
Thanks, Megan. Okay, let me present my screen quickly. Okay, thank you everyone for joining this webinar on Data Lake. So as discussed, we will go through everything about Data Lake, and then we'll see how to build a data lake, and I will show some demonstration on top of the use cases for the data lake. So let's begin. So everyone aware of this diagram? This is a star schema, which is a confirmed structure used to populate a data warehouse. As we are aware, it contains a centralized fact table, which contains the keys to dimensions and the measures, and it's surrounded by all the dimension tables, which has a different attributes, and we use this structure to analyze the data, to analyze those measures based on the different attributes which are there. Now, to put a data into this kind of structure, what we need is ETL, where we have a different kind of data sources, which are our line of business applications, which may be OLTP, ERP, CRM, or others. And then we perform ETL on top of that, where we extract data from all these sources and then transform that data to make sure we are loading that data into that defined confirmed structure, which is a star schema as discussed. Now, the data warehouse requires this star schema, which is a predefined data model, and based on the requirements of the users of the different reports or the questions needs to be answered to the business people, we design this data warehouse and create different fact dimensions and measures in a fact table and the dimension tables. As discussed, to process it, we require ETL, and then once the data is confirmed into data warehouse, the different business users can connect to this data warehouse and visualize this data, or get this data into different form, or they can visualize it in a visualization tool and analyze it based on the requirements. And we can also define or derive the operational reports or any other schedule subscriptions based on this data. Now imagine a scenario where we would like to add a data or add more points for analysis, which needs to be integrated with this model, and the data that point should be available for the users for the analysis. So the current process or the current state, what we are doing is, okay, we analyze those points, what are those, then we tweak our star schema, we change the dimension table, fact table as required, we add those all data points required, then we design our ETL, we develop our ETL and load the data again into data warehouse to get that data and repopulate all the tables so that those will be available for the business users for the analysis. Now, consider a scenario. This is okay for the business users, but what about the users which are the internal, like a data scientist or your data discovery team? They would like to analyze the data and they require it maybe in a raw format, or they require all the data points. In most of the scenario, we capture not all the data in the data warehouse, which is available for in the organization or on the internet, but we just capture a data which is only required for our analysis, which is mostly for the business processes to answer all the business questions. Now, in that scenario, another challenge is since as we know, the data size is also increasing. We are in terms of our SQL databases and our data, which is relational or the business data. But along with that, there are also introduction of various non-relational data which is available maybe in the different formats, like a social media data, a device data, or a cloud data, which also needs to be integrated and needs to perform a different analytics on top of that, so that it's also available for analytics. Now, if you think a data warehouse as a solution for that, probably we need to gather all this kind of data which is required for the analysis. We need to put all the data into data warehouse, and to do that, we have to extract everything data, transform it, and load it into data warehouse, which may lead to some challenges. So here, the users which are not the business users, or the users which require a raw data or the data as it is, or all the data, they need a different kind of data source and maybe a data warehouse, not a repository where they can look for that. So there's the data lakes comes into picture, and to drive this, and these are the needs of why we require a data lake. So as we discuss all the points over here, it's not possible to keep all the data which is required for future analysis, or which may require for the future analysis, but right now it's not required to. But it's available just to keep everything into data warehouse, so it cannot hold all the data required for the analysis. And then probably right now you don't know what data is needed, which in the future, but just it may needed in the future. You cannot store everything into the data warehouse, because definitely, as discussed, to store it into data warehouse, first, it requires a lot of space, since this data is not just not in a relational format or the structured format. We have to transform that. Also, the data is huge, which is generated by all these devices or the social networks. And even though we plan to store it into data warehouse, the storage is definitely very much expensive to support all the processing as well as the storage requirement for such a requirement for the analysis. So what is the solution for that? So definitely a data lake is solution. So let's understand what is data lake. So data lake is nothing but a central repository for all the structured, unstructured, or the semi-structured data, which can reside in a centralized location or centralized store in its raw format. So as you can see in the diagram, the data can flow, which may be structure, which is our transactional data, or the semi-structured data, which is our text or the data feeds, or the unstructured data, which is generated from a text, email, images, or audio file, or maybe some kind of social data, which is not very much structured. That all data we can gather into data lake and just store as it is. So as we discussed in the data warehousing, the method is extract, transform, and load. For the data lake concept, it's extract, load, and then transform for the analytics. So the first step is to extract this data from these different sources and store as it is into data lake, or just load as it is into data lake. So that's the extract and load part of it. Once the data is available into data lake, it's definitely available for analysis, and based on the users and their security for the different data provided to that particular data can be consumed by those business users. And since the data is available in the raw format and all the data is needed in the raw, it's there, the data scientists or those data discovery team can extract it. They can apply their own logic on top of it and do the analytics on top of it, and then it can be fed to a different application or maybe a data warehouse. Another area where a data lake can be used, since it's a central repository for all the data, and then whatever the data, maybe the higher granular data or just some few data points, those can be captured from the data lake, and the data pipeline can be built to populate our data warehouse on top of data lake. In some cases, it may not require to go to all the source systems and write the different ETLs to get that data for warehouse. Since the data is available in the data lake, it can be ingest from there, or the pipeline is created from the data lake, which is feeding your data warehouse as required on certain schedule. And so this is about the data lake and the concept, and which is used for the beneficial mostly for the beneficial of the data scientist or the data discovery team, where all the data is available for analysis, and then they can use it and perform any analytics on top of that. So let's see what are the benefits of doing this. So the data lake is a single repository for all the data. It can store structure, unstructured, and semi-structured data. Importantly, it can handle any volume, any variety, and any velocity. So any kind of data with whatever volume, it can handle with the same variety which is generating. It can capture into data lake. And more important benefit is it's available for analysis. They can perform whatever analysis. They don't have to go to the IT team or the data warehousing teams. Oh, we need these data points for the analysis. Just bring it those. They can directly connect to Data Lake and then do whatever the analytics require on top of that. So since we are discussing data warehouse and data lake, and then it may be a thought may become that, oh, is it data lake is a replacement of data warehouse? So answer is no. So definitely data warehouse and data lake are two different functions where you can, and the purpose of there is a definite purpose for using those. So let's go through all these 6 points where when to use what is data warehouse in that for those points, and what is data lake, and when to use what, and let's see the quick comparison on for that. So first point is a data. So data is in data warehouse, the data is very structured, processed, confirmed, which is coming through the ETL, and the schema is predefined where we are populating everything, which is used for mostly for the business process and just to understand how the business is going and then make a decision on top of that. Where data lake is consists of a very raw data, which can be structured, semi-structured, or unstructured also, and it's used for to perform analytics on top of it. In terms of processing, since for the data warehousing, the schema is predefined and then we populate data into that. Vice versa, in data lake, the data is there and we can define a schema on top of that, saying, oh, this is a file, so these are my column, and whatever the logic applies to that. And then since we can write a schema on read, it can be easily configurable later, even though your file structure changes. The users are the business professional for data warehousing, and data lake users are data scientists or data discovery team. In terms of storage, mostly data warehousing, it require a relational database, and it requires a SAN, and it's very expensive to store a large data in terms of volumes. But the data lake is designed for low-cost storage, where you can, and it's used as the distributed file system, where you can store enormous data, voluminous data into it, and then it can be used for the further analysis. In terms of change request, we have to go through the entire data warehousing lifecycle, starting from changing the ETL, your design structure. So it's very less agile. As compared, data lake is very much agile. It's configurable, and you can reconfigure. You can just change some parameter, and it's ready, and then you can do analysis on top of it. Since data warehousing is used from many years, its security mechanism is very much mature, and data lake is very much new, and its security mechanism is maturing, even though they provide access based on some of the file system. So this is the difference, a major difference between data warehouse and data lake, and then the clarification when to use what, and what is the specific use case for using that. So saying that, let's focus on how the data lake is fit into the Microsoft Azure Data Platform. So this is the Microsoft Azure Data Platform. This is a diagram which we are showing from various Azure Data webinar, and then you can see here the Azure Data Lake is at the bottom in the data sources section. So for the analytics or for the any kind of intelligence, business intelligence stuff, it's used as a data source over there. As you can see, the Azure Data Lake can ingest a data from sensors, data feeds, or your social media data, or it can also get a data. It can also ingest a data from the Azure Cloud SQL databases, and it also have a capability to ingest the data from your on-premises databases, where you can ingest a data from your all the line of business application databases to Azure Data Lake for the future analysis. Once the data is available, and definitely all this you can do using the Azure Data Factory, where it uses the ELT approach, where all the data from all these different sources can be extracted and loaded into Azure Data Lake. Once the data is available in the Azure Data Lake, you can do the T part, which is the transformation part on top of it, either using SD Inside, or you can use a Polybase if you would like to perform that kind of operation using SQL Server, Azure SQL Data Warehouse. So it has a ability to connect from Azure SQL Warehouse. Also, you can spin the SD Inside clusters on top of Data Warehouse and write your MapReduce or the Hive jobs to perform analytics and to get the data from Data Warehouse and do different kind of analytics. And as the platform supports, on top of that, platform supports the real-time analytics, predictive analytics, and the historical analytics, and which can be visualized using the Power BI or your Office 365 tools like Excel or SharePoint. And that visualization or the analysis can be done using your phone or slates or laptops or tablets or any browser, HTML5 supported browser. You can visualize all this data, which may come also from the data lake. So since we're talking more on data lake, let's focus more on the Azure Data Lake and see how it's being architected. So Azure Data Lake is distributed in the two function or two modules. One is a store, where you can store a structured, unstructured, or the semi-structured data into it, and there is no limit on your file size or the volume of data. So the storage is nothing but Apache Hadoop distributed file system in cloud, which uses the web HDFS to distribute all the file structure what we have, and which is very highly durable, available, and reliable storage available in Azure Cloud. So once your data is in this Azure Data Lake store, you can use different mechanism to analyze this data. So Azure Data Lake Analytics provides a mechanism to analyze this data either using SD Inside cluster or normal SD Inside cluster, or you can use a Spark on top of it, or Microsoft introduced a new language to analyze data in the data lake, which is called as USQL, which is a very simple a T-SQL-like language, and which is actually a combination of T-SQL and C#, and which is very extensible, where you can write a simple USQL queries and analyze this data from the data lake and develop a quick analytics application on top of that. So the analytics, it's also Azure SQL Data Lake Analytics. It's also built on the Yarn, and which is designed for cloud, and it can also analyze any kind of data and of any size of data, and which also provide a capability to develop faster and debug and optimize a smarter application or the analytics application on top of it. So this is the architecture of the Azure Data Lake. So how we put a data into Azure Data Lake. So as we discussed, we can use Azure Data Factory to do that. So as shown in the diagram, Azure Data Factory can connect to any kind of data source, which may be a SQL, your device data, or SQL in the cloud, or the tower data, or any other files, any kind of data which can be ingested into Azure Data Lake using Azure Data Factory. Azure Data Factory provides a mechanism to create a pipelines, and also provides a mechanism to schedule it, orchestrate it, and manage it, so that you have to just define a pipelines from the different sources, and then you can schedule those pipelines so that it can ingest the data based on the schedule which you define for that. And also you can visualize that the lineage that how my pipeline is working. So once the data get ingested using that pipeline into Azure Data Lake, the data scientist or the analytics team can prepare a data, then they can transform and analyze the data either using USQL or the HD inside. And once the transformed data, once the data get transformed, they can publish it back to the either to application or the warehouse or the SQL database, which can be consumed either using Power BI or any other visualization tool. It also provides a mechanism. Azure Data Factory also provides a mechanism to monitor health of your pipeline, and if it is failed, it can show you where it failed, why it failed, and then what schedule it runs. So you can automate all the process in the cloud easily. So now we know, okay, what is Data Lake and how to use Data Factory. So let's see how our solution will look like into Microsoft Azure. So as you can see in this diagram, Azure Data Lake is used as a common or a central repository where it can ingest a data from which is internet data, maybe from cloud or social media or from sensor. So you can ingest that. You can also ingest the data which is on premises, either from the databases or the data like your log files, web log files, or any other logs which you would like to analyze, but in the future. It also has a capability to ingest the data from the cloud-based databases like SQL Azure DB or any cloud databases. And once the data is available in the Azure Data Lake, you can use it. You can create different pipelines where you can push it to the Azure SQL Data Warehouse or to any other application, web application also. Azure Data Lake also provides a mechanism to integrate with the Stream Analytics, which is a real-time processing engine, while the processing or while Stream Analytics getting the data and analyzing it or the populating the Power BI dashboards in the real time, in parallel, it can also store that data into Azure Data Lake as it is, so that it can be used for the future analysis. And since all the data is available in the data lake, it can be joined with the different data sources in a single storage, and then you can define various algorithms or the analytics on top of that. So saying that, let's move to demonstration that, okay, how we can use build a Azure Data Lake using Azure Data Factory. So in the demonstration, I am going to show you how we can ingest the data from two different sources and how we can use the pipeline and how you can create a USQL jobs on top of Data Lake, which is creating some analytics. And then once the data is pushed to Azure SQL Data Warehouse through pipeline, how we can analyze it into Power BI. So let's move to the demonstration. So I will start. Previously, this is the Power BI. Okay, let me expand it so that I can explain it correctly. Okay, so this is the Power BI dashboard, and the scenario which I'm going to demonstrate over here is that I'm capturing a sales data. So this is all the dummy data which we are using the AdventureWorks database for that, and this is a data for a particular subcategory, which is tubes and tires, a category data, and this is a sales data which is showing the sales of per product, that how many orders, how many count of this product is being sold for that particular day. And it's also showing how much a heat map that, okay, which product gets sold more over there. So now what I'm going to do is I'm going to capture web logs for this particular days, and we are going to see that, oh, how many users or how many times this product get seen by the users, and then as compared to how many orders we received for that particular day, and from which area of the United States those views are coming, and then which product is most likely be seen by the users. And we can compare it with the sales data so that we can understand what users are seeing. It's that so how many users are viewed that product, and then how many users purchase that product on particular day, and then if the certain product is seen more but order less, then what we can do, can we provide some offers to the business to the users on that particular product over there. So saying that, let me go back to Azure Data Lake. So this is Azure Data Lake, which we have created, and then we have created these folders. So this is the folder structure for the Azure Data Lake, and then I'm going to store a web logs over here. Right now there is nothing over here. So what I'm going to do is I have already defined a pipeline for getting a data from Azure Blob Storage. So for the demonstration purpose, we are storing all the web logs at a particular location in the Azure Blob Storage, and which we defined a pipeline which is continuously monitoring that location, and then once the data is available at that location, it will store that data into Azure Data Lake. So let me copy a weblog file so this is Azure Explorer where you can connect to your Azure Blob Storage. So I'm just copying a weblog file, which is event data at this location, and then this being captured by Data Lake once I run that. So let me run this purposefully. Okay, so in the meantime, I can explain other things to you over here. So as you can see, these are the different pipelines which are created for different activities to get a data into Data Lake, and as well as there is an activity where once the data is being processed, there is an activity to push it back to the SQL. There's a pipeline to push it back to SQL Azure Data Warehouse. So I will explain that too, how it works. So the first step is to capture the web log. In the parallel, we are also capturing a data from the Azure SQL database, which is, you can consider as a transactional database, where we are capturing data related to customers or the items or the products related information, which is kind of metadata which may require for the analysis in future. So as shown, so Data Lake can accept any kind of input, and you can store any data into Data Lake. So the data in the Data Lake, it gets stored in form of files. So this is the Data Lake which we discussed, and and this is the every data gets stored in terms of file. So this is the file which I copied over here, 701, and now that pipeline get run, and then it's also available over here in the Data Lake. Along with that, I will just show you. We also captured data which is from the database, and the file for per table is being created. So I captured a data for the customer, but you can capture a data for all the tables which can be stored in a Data Lake and used for different analytical purpose. So the next step, now the data is available into Azure Data Lake. This is the web logs data, and now what I'm going to do, I'm going to process this data using useSQL, and I'm going to create an aggregated file which I'm going to store over here. So Let's go to my USQL job. Okay. Okay. So Microsoft Visual Studio also provides Azure Data Lake module, which you can install and write a USQL on top of it. So this is a simple USQL I wrote where I'm reading a data from that event log file, where I'm just reading all 4 columns from it, and then what I'm doing, I'm just aggregating a data from that file for the particular product and particular city, and just want to know how many visitors visit for that particular city and that product in that. So I'm just reducing a grain of that data for that particular day, and then in the next step, I'm just storing that output as event data summary back into the Azure Data Lake. So let's run this. Let me submit this job over here. Okay, so what it's doing in the background is it's preparing a data. It's trying to see, oh, what are the files provided, how that file structure is looking, whether all the columns are available over there. So it's preparing everything, and then it will analyze, okay, how much processing, how much RAM, everything is required for that. So since my current job is very small, it just requires one job or only one vertices. So the term for the one particular job, they call it as vertices, and then for now, for this very simple job, I just need one vertices. But as you can analyze very large data on top of the data lake, and you can write this USQL to just process a very large file or large files into top of that. Based on the load and the structure, it can create multiple vertices and then assign that job parallelly. Those can be executed in parallel to perform the activities over there. So here it's already executed, and it's already saying that's 100%. So let's see, my event data summary file is being created or not. So the job is completed, and we can go to, oh, okay, so I have to just refresh this. Okay, so the file which is created, the output file from the USQL job is being created, and now you can also analyze this data. You can see that file. It's stored over here, and it says for the product ID 480, there are 4 counts from the Las Vegas. There are 2 counts from the Miami, and something like that. So now this data is there in a data lake, which is the process data, or you can say clean data or aggregated data in case of our demonstration. Now the next step is to create a pipeline and push this data to data warehouse. So we have already created a pipeline for that, where it's, okay, let me show you in detail. Okay, so this is taking Azure Data Lake as an input, and it's creating the pipeline has been created to store a data into Azure SQL Data Warehouse. So let me run this. Last time it failed because there was not a file. So let me just quickly run it so that I can insert a data into our SQL Data Warehouse. So here I'm using the table where I'm storing the data, and then once the data is available, it can be seen over here for the analysis. So let me see if the job is done. Okay, so I think it's executed. Okay, so data is there, and I can show you that over here, but let's see it in this dashboard. So let me refresh this database so that you can see the comparison. Okay, So let me expand it. So this is the aggregated data which is coming from for that particular product. So I'm saying this, since I'm doing this for the one day, it says, oh, this product patch kit is actually being seen by 12 people and eight people order it on that particular day. And then you can compare. Definitely, in most of the cases, your page views are more than the order. In some cases, there is an order, but there is no page view. So there is something wrong, or we miss some data. So this is how you can, data scientists or data team, can find the analysis, do the analysis and the comparison of the data. They can also see a data, oh, all these page views for this, these are coming from which area. So it says, oh, those page views coming from California, the Las Vegas, those are coming from the Las Vegas, then 9 from the Kansas City, 15 from St. Louis, 15 from Skokie, and there are some 7 page views are from the Miami. If you would like to see those page views for a particular product, you can just click on that, and then you can see, oh, okay, for this particular product, there are 5 page views, and 3 comes from St. Louis, 1 from Skokie, and 1 from Miami. So this is how you can analyze the data. And this map is showing, okay, what was a product heat map for the products. So it says, oh, patch kits, the 8 patch kits were sold on that particular day. Then the road tire get sold, which is more. But if you see the page view heat map, it says, oh, okay, there were 12 visits for patch kit, but there are 9 visits for LL mountain bike tires. But in terms of sell, there are only 3 products getting sell instead of, even though we got a 9 page visits for that. So okay, we can, so people are seeing that product, but not those many conversions are happening. So they can analyze, okay, we can do something more, or either we can provide some offer on that product or something like that. So this is how you can actually, the data scientist team or the analysis team, they can actually connect to your raw data, and then they can visualize, they can create a pipelines to for the data warehouse or their different applications, or they can visualize it in visualize it in Power BI, or just analyze whatever the analysis they want to do, and then once that is confirmed, that they can publish that analysis into different applications or database as a pipeline. So that is from this demonstration. Let's go back to our presentation. So what we've seen in the current presentation, that how we can get a data from Azure SQL DB and the web logs, and then how we can integrate it with the Azure SQL Data Warehouse, and then how we can visualize it into the Power BI. We can also provide or analyze this data and then send this data to a different machine learning algorithms. And once the data is prepared or analyzed, it can be also sent to the Power BI, which is we have final output of the algorithm, or all the scores. We can store it, either store it into Power BI, or we can store it into Azure SQL Data Warehouse, or we can send the scores or the recommendation, whatever is there, to the application. So in the next webinar, similar on the data lake, we'll also cover a demonstration where how we can integrate Azure Data Lake with machine learning, along with how we can integrate right now with the Azure SQL Data Warehouse. So that's it from the demonstration part. So hope you got it, that what is data lake, how to use, why it is needed, what it is, and how to create a data lake. So why not to take advantage of data lakes and to create your data lake into Azure SQL Data Platform. So by using Azure SQL Data Platform, you can focus on your analytics, and create a data lake, and you don't have to worry about all the infrastructure needed to create your own data lake. Once your data lake is created in the Azure Data Platform, you can store voluminous variant data with the higher velocity. You can provide a secure access to the users for the data, and then you can perform any analytics on top of that on any size of data. So that's the biggest advantage of creating a data lake into Azure SQL Azure on the SQL Azure Data Platform. So saying that, if you would like to take advantage of data lake, and if you are found it interesting, and and you would like to create a data lake for your data scientists or the data discovery team, or just you want to store the data for now and then which can be used for the analysis in future, please contact us, and then we can help you to how you can take the advantage of Azure Data Lake, or our expert can help you to get it there to build your data lake in Azure Cloud. So do contact us at info@densolutions.com. Thank you for your time for attending this webinar. Megan, please let me know if you have any questions for me.
Okay, thank you, Sunil, for your presentation. Great job. If anyone out there has any questions, please feel free to enter those now. Otherwise, please enjoy the rest of your day, and thank you for joining us today. We'll stay on the line for a few minutes to discuss any questions. Okay, looks like no questions have come in. If you do have any questions in the future, again, please email info@densolutions.com. Thank you, Sunil, for your presentation, and thank you all for joining us today. Enjoy the rest of your day.
Thank you.